We're now going to look at the other special case in which we have no unique solution. So again, you don't need to write anything down here. I just want you to pay attention. So let's come over here and talk about no unique solution. So this is when you have a dependent system of equations. So dependent. So if you were in a situation and you're asked to solve these systems of equations here, what would you do? Well, you'd first set them out. You'd say, all right, I've got 1, -1, -2, 2, x, y, -1, 2. Then we call this a, we call this x, and it's equal to b. To find what x is going to be, we're going to take the inverse of a and multiply it with b. So let's now do that. So I'll come here and I'll go, all right, I have this, 1, -1, -2, 2, and then I will define that as a. And then I'll go again, I'll come here, I'll go to this one here, and this is -1 and 2, and I will call this one b. And now if I go a, the inverse of a multiplied by b, I'm going to get this again, which is singular matrix. And you know, when it says singular matrix, that means you can't find the inverse of a. It means that the determinant of a is equal to 0. But now you might be asking yourself, well, how do I, because remember when we did inconsistent systems of equations, it came up with the same thing about the singular matrix. So how do we kind of differentiate between having a dependent system of equation? So that's when there is no unique solution, meaning that there are two equations are equal and the lines intersect at infinitely many points. So in other words, you've got the same line. So we call them dependent because each line is dependent on each other because they're the same thing. There's an infinite amount of solutions here. How do we tell the difference between this situation and the inconsistent system of equations when they don't touch at all? Because remember, we got the same error message from our CAS calculator about a singular matrix. So how do you differentiate between having an inconsistent system of equations and a dependent system of equations? Well, what you have to do is look at your initial equations that you were given and realize that these two lines are the same, because if you were to multiply each of these terms by the same thing, you're going to get this one. And we saw this before. If I was to multiply each of these by -2, I'm going to get this, because -2 times x is -2x, -y times -2 is +2y, and -2 times -1 is +2. So you have to be able to recognize that these are the same, because you could multiply this. So you could multiply this entire thing by -2 and it would become that. So that's how you tell the difference as to whether or not you've got a dependent system of equations or an inconsistent systems of equations. Hopefully that made sense, and I'll see you in the next part.